Hey guys, welcome back to Test Driven Development Playlist. In the last video, we have discussed mocks and stubs. Today, in this video, we're gonna discuss all of the features of our mock. Because it's a vast library, it provides a lot of features that we can use in our unit test cases to mock the responses. So for this, I have already prepared few class, interface, and object just to show you how you can use this mock library with all of these things. Let's get started with our video, and first thing first, I'm going to show you the code that I have already prepared. Here we have counter use case. It depends on counter repository, and counter repository is an interface that has few non-suspendable function, two suspendable function, and one suspendable function that has callback. And I'm going to show you how to use mock library with all of these things. Apart from this, if you open our counter use case, first let me show you the implementation of our repository. It's very simple. I have created here a private variable count. Get count, return the count value. Increment help us to increase its value. Decrement help us to decrease its value. And when you call reset, it simply set your count to 0. Save count in database will eventually update the count value. Load from network, so it pretends that it calls the network and then give back the response with the help of our callback. Delay is 1 second, and after that we'll use this callback and pass the network response, which is nothing but an integer value of 200. This is the implementation of my counter repository implementation. Open your counter use case. We have few functions in it. First function load count, which uses the repository get count function. We have increase, decrease, reset counter, persist, which uses the save count in database, or you can say it use save count in db function of our repository to update the count value. Get count from network. This function is used to fetch the information from the network. We'll use repository load from network and return the result with the help of onResult callback. Compute with helper. Under the hood uses counter helper. Control click on this counter helper. We have basic three functions: multiply, subtract, and add it. Multiply, simply multiply the given value by 10. Subtract minus 10 to the given value, and add it plus 10 to the given value. And we have one more function in our counter use case, which is this conditional reset that uses application configuration should auto reset. Application configuration is an object. These are the functions we have in our use case. Now let's begin with our test cases. So for that, open your unit test directory, and in this part 4 I want to create here a class, and the class name is counter use case unit test. Use test function, give the name when increment call should trigger the increment of repository. In this particular test case, I want to verify that when I call increment function of my use case, it will trigger my increment function of the repository. So how we can verify it? Well, first thing first, we need a mock of our repository. Use here a variable naming repository, use mock library, mention the type, which is counter repository. Create a use case, counter use case, and pass your repository in it. So now we have a mock repository and we have a instance of our use case. So when use case call the increase function, it will trigger the repository increment function. So what will happen when we trigger a repository increment function? Because I have already created repository in a form of mock, we can mock its result too. How we can do it? Well, to do it, we have here every function, and in this every function we'll use a repository increment. So what action we want when repository increment function got triggered? In this case, I want to use a returns 10. Open the counter repository increment function. If you see, return type is integer. That is why I'm returning here 10 value. You can return whatever value you want. Okay, so now we have triggered this increase function, and this increase function will trigger increment function. So to do that, we'll use here verify. Just pass your repository increment function, and I want to verify that this function call happens only one, exactly one. This verify help us to verify how many times your function got triggered. Every increment call returns 10. So this line help us to mock the return type of our increment function. Verify help us to verify how many times this function triggers, and I am expecting exactly one time, right? Execute it. Alright, so our test case passed successfully. Now open your counter use case so you can write this and this test case by yourself. Now I want to show you how we can do the same thing for suspendable function, I mean the reset counter. So for that, open your test case, create a test when reset called should trigger the reset of repository. Again same thing, create a mock of our repository. Type is counter repository, create an instance of our use case, counter use case, pass our repository. By the way, this is arrange section, and this is action, or you can say act, and lastly the assertion. We have already seen what is AAA pattern. Same goes for here. This is a arrangement section. Next we'll use every repository dot reset, then it returns unit, because if you check the return type of reset, it's nothing. We have a problem, and the problem is this is a suspendable function and every doesn't support it. So to use suspendable function or to mock suspendable function return type, we'll use here coroutine every. Just add co as a prefix and it works. Alright, so now it's time to perform action, or you can say act. Use case reset counter. Again, this is a suspendable function and we are not present in a suspendable function. So to test suspendable function, we need to use here a coroutine builder naming run test, and this run test is specifically designed for our testing. Now lastly we will use assertion. In the assertion, again I want to verify, because it's a coroutine verify, we'll use coVerify. Exactly one time my repository reset counter will be triggered. Execute it. Alright, so test passed successfully. So we have seen two things here. We have seen how to use verify, how to use every, and also how to use every and verify with suspendable function. In the next test case, I want to verify that if I call use case increment and decrement in order, then it shall trigger the repository function within the same exact order. Let's see how we can test it. So write here a test case. Let me make some space for you. Function when increase or increment and decrease called should trigger the increment and decrement of repository in order matter here. Now again we're gonna use here AAA pattern, arrange wall repository mock counter repository, create a use case, counter use case, pass a repository in it. So every repository dot increment, we're gonna return here 0 or let's say 1, and every repository dot decrement, we're gonna return here 0. So we are done with our arrangement. Now it's time to perform action, or you can say act. Use case increase, use case decrease, and I want to verify if I call my use case like in this increase and decrease order, it shall trigger my repository in the same order. So it's time to perform assertion. We'll use here verifyOrder, and in this verifyOrder you'll use your repository increment and repository decrement. So it will provide you an ability to test the order of execution of your mocks. Execute it. Alright, so it's fine, it is working. Similarly, we have one more function to verify whether the things is executing sequentially or not. So for that we'll use a function naming verifySequence. Let's just duplicate this thing. And at the end I'm gonna add here sequence. Just change this thing from a verifyOrder to verifySequence, and if you want to verify sequence of a coroutine or suspendable function, you shall use coVerifySequence. It's the same thing. Try to execute it. Okay, so test passed successfully. Now the thing is, what's the main difference between verifyOrder and verifySequence? So I'm gonna elaborate you with code. Open your CounterUseCase and just change few codes in our increase function. Use your pair of parentheses, just cut this thing out, create a variable naming result, and in this result store the result and return this result, and in between call load count function. So load count function eventually uses get count functionality of our repository. Come back to our CounterUseCase unit testing and add this particular line. Same goes for the sequence one. And now try to execute these two test case. So first let's execute order one. It passed. Scroll down, execute the sequence one. It fails. Well, now the main difference between them is in verifyOrder, extra calls allowed in between these two functions, increment and decrement, but with sequence it is not the case. You will never call other functionality of your repository in between these two function. This is the difference between verifyOrder and verifySequence. I hope the difference is clear to you. Alright, so scroll down, let's write one more test case, and in this test case I want to show you how you can mock an object. So for that, open your CounterUseCase. Let me show you the functionality that we're gonna write unit test case for. This is the functionality, conditional reset. Open your CounterUseCase unit testing, and when conditional reset is called, should trigger reset of repository. Again, I'm going to create here a repository instance with the help of our mock CounterRepository UseCase, CounterUseCase repository. Every repository reset, I wanna return here unit. It's a suspendable function. Use here coroutine every. Now it's time to perform action. Use case complex computation. Let me just verify what was the function name, and the function name is conditional reset. Use this conditional reset. Again, this is a suspendable function. Use here a run test coroutine builder. So arrangement is done. Action is also done. Now it's time to verify, and we call it assertion. So in assertion, we shall verify that our repository reset will be triggered once. coVerify exactly one repository reset. So now it's time to mock an object. In our CounterUseCase conditional reset, if you notice, we'll use here application configuration should auto reset. It's time to mock this application config, and application config is an object. Come back to our test case, and here at the top I want to create app config, mock object application config. So for every application configuration dot should auto reset, we're gonna return here true. Execute it. Okay, so test case passed successfully. Open your counter use case. You notice should auto reset is always false. So that means our application configuration mocking will work. Next, we're gonna see how to mock constructor. For that, open your counter use case and we're gonna write unit test case for compute with helper functionality. Come back to our unit testing and here we have a function when compute with helper called should return correct value. So first create a repository. Next we have instance of our counter use case. If you notice in our counter use case functionality of our compute with helper, under the hood it uses counter helper. So in order to make this test unit test, we need to mock our counter helper, because if we are not able to mock this counter helper, eventually it become integration testing, because in integration testing we test more than two components working together, but here we are writing unit testing, not an integration tests. Come back to our unit test. It's time to mock our counter helper constructor. So mock constructor, mention the class. So class is counter helper class. Next, for every repository dot get count, we gonna return 10, and for every multiply of our counter helper, so any constructed, mention the type, and the type is counter helper dot multiply any. So basically in multiply we need to pass the current value, and I'm simply passing any value. So you can pass 1, 2, 3, 4, whatever you want, but at the end it always return 999. So you can use whatever the number you want, but I think 999 is good. Okay, so we are done with our arrangement. At the top, use here comment arrange. It's time to perform action. Use case dot compute with helper. Take the result in result variable and perform the assertion. So in assertion we'll use assert equal. Let me import this assert first. Assert equals, and my expectation is 999. And we're getting back the result from our use case. Execute this unit test case. It passed successfully. Alright, so let's go one more time with this test case. So in this test case, first thing first, I have created a mock of our repository, create an instance of our use case, because in our function it uses counter helper. And if we do not mock this thing, eventually it become an integration test. So to mock this counter helper, we'll be using here mock constructor, cause when you use counter helper, then this two smaller bracket or circle bracket, eventually it invokes constructor. Because it invokes constructor, we simply mock its constructor, and after that we'll write the return type of our get count. So when repository get count functionality trigger, it returns 10, and when any constructor of type counter helper calls multiply with any number, I'm gonna return 999, and this call happens in our functionality at the end, helper.multiply. So it eventually returns 999, and this is what happens when we call this compute with helper function, and at the end it returns the result, which is nothing but 999, and we simply verify here. This is how you shall proceed with mocking the constructor. But now the most important thing is to free the resources. So unmock constructor, mention the type, which is counter helper class, and also you can clear the mocks. In clear mocks you can pass everything, like here I'm gonna pass repository. Similarly, if you have application config object, you can pass that thing too. Basically it's an var arg. You can pass multiple argument in clear mocks function. Okay, so we just saw how to mock a constructor. Gonna see how to mock callbacks. For that, open your counter use case and we have function get count from network and persist. It uses callback, and I'm gonna show you how to mock this kind of functionality. Under the hood it uses load from network. So if we mock the repository, we need to mock our callbacks that is present in our load from network function. Come back to our counter use case unit test and create here a test case. When this particular function calls, should return correct value. So first, arrangement. Let me make some space for you. So in the arrangement, we shall create our repository. Mock the counter repository. We have instance of our counter use case. Pass the repository. Now for every repository dot, we have load from network function. With any callback, I wanna answer. And in my answer, first let's prepare my callback. Argument, mention the type. So my type is suspendable integer, return type is unit, and we wanna grab the first argument. Callback shall return 200. It's time to perform action. Create here result naming variable, use your use case, get count from network and persist, and in this we'll retrieve the result. Create here a variable naming not result. This time I want to call it network count. Initial value is -1 and its value will be updated within this callback. And again, this is a suspendable function. Use here a run test coroutine builder. So my callback return 200. It's time to perform assertion. Assert equals, and my expectation is 200 network count. Okay, execute this particular test case. Okay, so it works. So to mock callbacks, we will use this approach. I want to see how to use Spy. So to use Spy, open your counter use case and first go through with this function. So in complex computation, we are using counter helper. We are using get count functionality of our repository, grab the current value. We'll use helper subtract, pass this current value in it, get the result in a subtract variable, and after that we'll use this subtract variable, or you can say subtract value, within our helper.added function, and at the end it will return this added. Now it's time to write its test case. For that, open your counter use case unit test, copy this function name, come back to our unit test cases, create a test function. When complex computation called should return the correct value. So first thing first, we're gonna arrange everything. Every repository get count will return 10. Under the hood, our function uses counter helper. So mock its constructor because we are writing here unit testing, we are not writing here integration testing. So mock constructor counter helper class, and also I wanna attach here spy k over counter helper. It uses my subtract and edit functionality of counter helper. So we need to return the result too. Come back to our counter use case unit testing. By the way, spy is used when you want to mock your classes, your object partially. That means under the hood it uses the real implementation of our counter helper in this case. So any constructed counter helper subtract, we gonna answer with the help of our spy dot subtract first argument. So this first argument says that when counter helper dot subtract function called, you simply take the argument and provide it to spy so that we can later on check whether this function is called with correct value or not. So we are done with the subtract. Similarly, we need to do for added. Counter helper added any answers spy dot added first argument. So if you have more than one argument, you can use second argument too, but in our case we have only one argument. It's time to perform action. Use case dot complex computation will have here my result. It's time to perform assertion. Open your counter helper. You see in subtract, current value will be decreased by 10. With added, current value will be increased by 10. Come back to our unit test case. For every get count, we are returning here 10. That means this subtract function will be called with 10 argument, and this added will be called 0. Just verify it. So verify spy dot subtract. This subtract has argument 10. Similarly, we will be verifying spy dot added. We have value 0. I mean the argument is 0 for added functionality. At the end, we'll use assert equal. We have our result and my expectation is 0. So here we are actually verifying the argument, and here we are verifying the result. Execute it. Okay, so it fails. Let me see why it is failing. Expectation is 0 but actual is 10. Well, this is because when our added function is called with argument 0, it simply add 10 to it. So 0 plus 10 eventually become 10. So my expectation value is wrong. It will be 10. Execute it. Wow, it passed. So yeah, that's it for this video. In this video, we have discussed all of the feature that mock library provide us to mock our callbacks, our objects, our classes, constructor, etc.